There are periods in our history known as the Dark Ages, when matter and energy existed but there was no enlightenment or understanding. In contrast, today we live in an age where every aspect of our lives can be recorded via the internet. We can easily record every detail and upload it online for future generations to continue to use. However, for those of us living in the present, uncovering the past is never an easy task. We often invest countless hours of research to piece together the historical story. But these efforts offer ideas that could shape our future. Recently, researchers have begun to obtain interesting chemical data from various surfaces in the universe, and they have revealed an unexpected surprise. As part of this research, scientists have identified regions where entire galaxies have disappeared and been replaced by completely new ones. This discovery has profound implications that change our understanding of the universe. Join us to uncover the mysteries surrounding our disappearing galaxies and find out what their absence means for our future. One particularly fascinating mystery is the Great Unconformity, a geological mystery that has puzzled scientists for decades. This phenomenon represents a significant gap in the geological record, from 100 million to 1 billion years, during which time there was little geological activity on Earth. It is as if the Earth's geological clock simply stopped at this point. The thought of such an unrecorded period is unsettling, because we are talking about millions of years, not just a few lost years, and it is impossible to understand what happened or how the Earth recovered. Most geological mysteries are based on theory, but in this case, there is a lot of evidence to support its existence. The Great Unconformity is recorded in various rock layers around the world, appearing differently depending on the location. Sometimes it appears as a simple moment in timeline, and sometimes it appears over a vast period of time. It is one of the most significant unconformities ever discovered. Interestingly, the Great Unconformity is not simply a matter of missing species. Most of the geological structures that existed during this period have eroded away, leaving little evidence of their existence. The rocks that remain at this time show clear signs of weathering and erosion, indicating that they have been exposed to the natural environment for a long time. This makes us wonder what happened in this mysterious chapter of Earth's history. One popular theory is that the planet experienced extreme weathering and erosion, which effectively destroyed the existing rock layers. Another theory suggests that major tectonic events destroyed these rocks, forming new layers. Geological evidence supports the idea that Earth has experienced other significant tectonic events in the past. Likewise, the universe operates according to its own mysteries. Just as the Great Void exists on Earth, there is a vast void in space beyond our understanding, a region devoid of galaxies, stars, and even dark matter. The question is, what event caused so many galaxies to disappear, and could this phenomenon occur elsewhere in the universe? The Great Void is a mysterious phenomenon that has intrigued scientists for years. Its immense size and emptiness make it a unique and fascinating subject to study. Located within the Eridanus supervoid, this vast region spans nearly 1 billion light-years, and the void itself is estimated to be about 300 million light-years across, making it one of the largest known voids. It is not completely empty, but it is noticeably less dense than the surrounding region. Researchers are trying to understand the origin of the void, proposing several theories. One of them suggests that a primordial black hole formed early in the universe, absorbing surrounding matter and leaving behind a gigantic void. This black hole could have been created by small quantum fluctuations in the expansion of the universe as it grew. The evidence that black holes are swallowing up large parts of the universe raises the question: could a black hole ever accumulate enough energy to consume an entire galaxy? Another theory postulates that cosmic strings, hypothetical thin, incredibly dense objects that formed in the early stages of the universe, could interact with surrounding matter and gravity to push matter away, creating large empty regions like the Great Void. This scenario means that dark matter and other celestial components are not needed to explain the space created by this displacement of matter. Another explanation for the Great Void suggests that it is simply a manifestation of cosmic variability, a phenomenon in which the universe exhibits large-scale heterogeneity. Just as some areas of a photograph may appear more crowded than others, some areas of the universe are naturally less populated. The Great Void could simply represent one such example of this cosmic variability. But what if we have been misunderstanding the structure of the universe? The concept of an expanding universe, first proposed by the astronomer Edwin Hubble in the early 20th century, showed that galaxies are moving away from us at an increasingly faster rate as they move away from us. This led to the realization that not only was the universe expanding, but that its expansion was accelerating. This was a startling discovery made in the late 1990s. Observations of supernovae, or exploding stars, revealed that an unknown force called dark energy was responsible for this acceleration. The nature of dark energy remains one of the most important mysteries in modern cosmology. As the universe continues to expand and accelerate, galaxies will eventually move farther away from us, faster than the speed of light. This means that not only would we lose the ability to reach these galaxies, but their light would also dim, effectively disappearing from our perception entirely, making it impossible to observe them. The universe we live in is made up of a vast variety of galaxies, stars, planets, and celestial bodies. Surprisingly, the oldest light in the universe, the cosmic microwave background, CMB, still exists today. Discovered in the 1960s by radio astronomers Arno Penzias and Robert Wilson, this radiation is a remnant of the Big Bang, the event that created our universe about 14 billion years ago. The CMB is the afterglow of this gigantic explosion that created everything, including time and space. The universe was initially hot and dense, but as it expanded, it cooled enough for the first atoms to form about 380,000 years after the Big Bang. During this phase, light moved freely through space, eventually emerging as the CMB we see today. The CMB serves as a snapshot of the universe as it was just 380,000 years ago, providing invaluable information about its early state. By analyzing temperature changes in the CMB, scientists have gleaned important information about the early universe. These changes, caused by small fluctuations in the quantum density, were amplified by a phenomenon known as cosmic inflation, the unusually rapid expansion of the universe after the Big Bang. While the CMB illuminates many aspects of the early universe, it has also revealed anomalous phenomena, such as the CMB cold spot, a noticeably colder region in the CMB. This cold spot, about 70 microkelvin colder than the average temperature of the CMB, spans a radius of about 5 degrees, much larger than the typical fluctuations found in the primordial CMB. Various theories have been proposed to explain this cold spot, ranging from statistical anomalies to the existence of supercavities and exotic physics such as the existence of parallel universes. Furthermore, the mystery of dark matter continues to challenge our understanding of the universe. Dark matter, an elusive substance that makes up much of the universe, plays a key role in galaxy formation. However, some dwarf galaxies have been found to contain much less dark matter than expected. Researchers have identified 19 dwarf galaxies that deviate from our expectations about the distribution of dark matter. Traditionally, dwarf galaxies are thought to contain significant amounts of dark matter, which is typically higher in concentration than normal matter, due to their small size and weak gravity. But these outliers challenge that notion. Scientists, including astrophysicist Kyle Oman, investigated how dwarf galaxies formed and why they contain such small amounts of dark matter. Oman and his team first identified 2 galaxies in 2016 that did not appear to contain dark matter, and now they have found 2 more. There are currently 19 dwarf galaxies on the list, all within about 500 million light-years of Earth. In some cases, researchers suggest that neighboring galaxies may be spewing out dark matter. But the rest are isolated, raising questions about whether they formed differently or were affected by events such as stellar explosions that upset the balance between dark and regular matter. Astrophysicist James Bullock of the University of California, Irvine, argues that this may not be the case where dark matter is absent altogether. These dwarf galaxies may have retained or even gained additional amounts of normal matter. This discovery highlights the diversity of galaxy formation and forces scientists to rethink existing models of galaxy evolution. Understanding dark matter and its role in galaxy formation is crucial to understanding the entire universe, including our own galaxy. The prospect of galaxy disappearance is alarming and prompts us to consider how we might prevent such an event from happening in our own galaxy. The threat may not be immediate, but we must remain vigilant in our efforts to understand and protect our cosmic home. If you have any thoughts on these revelations, please share them in the comments below. If you like this video, please give it a like and subscribe to our channel for more interesting content. We look forward to seeing you next time.